a good Wednesday morning to you as we kick off a rainy day here in Northern Virginia. We can expect rain today and Friday for your local weather forecast for those of you in the area. Today, you can see that we have hoisted the pirate colors, and that means we're going to talk about some attacks. Today, the attacks will be at network devices as it relates to the Security Plus exam. If you've been following along this week, covered the OSI model. We covered the basic types of network devices, hubs, bridges, routers, switches, that kind of stuff. So today we're going to talk a little bit about what we can do to protect those and what types of attacks we kind of see coming against them. So we have our cup of illy coffee and our great Smoky Mountains cup, and we will dive right into that after our little intro. The cup of cyber. Today is August 24th. It is not August 24th. It's March 25th, but it is National Waffle Day. Didn't even notice that date was so wrong. What is going on here? So enjoy a waffle today, I guess. Well, probably not going to go to Waffle House. Maybe you have to have an Eggo waffle or something. But today, we are back into Security Plus, the CompTIA Security Plus topics, domains, common body of knowledge, that kind of junk. And we are talking about network design elements, and the subtopic is network device attacks. So, when we talked about the different devices, remember that the hub, I got rid of them, moved them away from here. The hub was kind of a dumb device. It just, traffic came in one side and it went out all the ports. So if you had 5 ports on your hub, all that traffic coming in went out all 5 ports, right? So we said switches were more secure generally because they have the ability to know where that traffic is going. So when the traffic comes in one side of the switch and is destined for a specific computer, it only goes out that single port that computer is connected to. That's the theory. That's how we define that switches are a bit more secure than hubs, right? The way it does that is within the switch, there's a table. And that table just says, this computer is on this port, and we identify it by this MAC address. And really, we don't even say that computer's there. We just say, this MAC address is on this port, right? And with this, we're talking about a layer 2 switch. We're not talking about layer 3 switches. We know there are layer 3 switches out there. We're not talking about that here. We're talking about those layer 2 switches. So, so we know that this MAC address is on this specific port within the hub. So we know that if we have 5 ports, we should have 5 entries in our table, and each of those should be a port and an associated MAC address if something's connected, right? What we do in a MAC flooding attack is we try to overwhelm that table, and it's called the Content Addressable Memory, or CAM table, and we just try to get that table to shut down, that part of the switch to shut down. And with devices, we can fail in 2 states. We can fail open, or we can fail closed. With a device like a firewall, we may really want to think about maybe possibly failing closed. And that means when the device fails, when it's overwhelmed, all the ports shut down and no traffic can get through. That may be an issue. If no traffic can get through, then the network stops running, right? So a lot of times switches will go to a fail open mode. So when they're overwhelmed, they essentially act like a hub. They fail completely open, right? And that's what we want to do. We want them to fail open, and then they act like a hub, and then when traffic comes in one side, it goes out all the ports, right? If we have a protocol analyzer, and these aren't crazy expensive or anything, a lot of times you can get software like Wireshark for free, and we set our computer up in promiscuous mode. We plug into the switch on an open port. If we can flood the table, we get all the traffic, and then we can read the traffic with the protocol analyzer with something like Wireshark. Obviously, because there's so much more traffic on the network, it's going to slow the network down. So we're going to have a slow network. So that's going to be a sign of possibly MAC flooding. We're going to get a slow network. And the bad thing is the attacker is going to have the ability to, if they can get in, if they can read that traffic, they're going to have full access to everything, right? That's going on, at least on that switch. And think, the home switches. Our home switches are, 6 ports or 5 ports, something like that, 10 ports maybe. In an environment, in an organizational environment, maybe you've got 24 port switches or bigger, where there's a lot of different computers or different systems connected to those switches. So definitely could be detrimental, right? Another thing, and when we talked about the OSI level, we talked about the difference between an IP address and a MAC address, right? And we kind of relate it to the MAC address is kind of like your social security number, and an IP address is kind of like your address, your house address. So the social security number you have shouldn't change. It should be the same throughout your life. Now, obviously, you're nefarious. You go out and change your social security number. You're trying to do evil and crazy things. You can change your social security number. But generally, people keep the same social security number their entire lives. You may have several addresses, right? And that's the same way the network card works, right? Your network card has a specific MAC address that is assigned to it when it's built, and that generally stays with that network card through its entirety, through its lifetime, right? The IP address will change, right? Go from network to network, it's going to change. Sometimes even on the same network, different times, it can change. So with MAC spoofing, we can use software, and we can go in and manually change our MAC address. So if I know a MAC address of a computer on that network, on that switch, and there's security measures in place that's going to keep me from getting on the network, or maybe I want to get on the network and I know that a specific MAC address is on a computer that got shut down, and I know that's in the CAM table. If I plug in and change my MAC address to that computer's MAC address, when traffic is routed to that computer, that MAC address at least, it'll come to me, right? We're trying to fool the switch into sending data that's destined for that computer with that MAC address to us because we've changed our MAC address. And sometimes we need a specific MAC address to get on to a network, right? The way a MAC address works is the first part of the MAC address is assigned to a specific vendor, whoever made the network card, right? So if we have a network card made by Dell, the first part's going to be identifier for Dell. So, and then the last part's going to be unique. Maybe we know in our organization we're trying to build security around our environment, and we know all our computers are Dell and they got Dell network cards. We say only MAC addresses that start with these sequences that are assigned to Dell can be on the network. So maybe we can spoof our MAC address and we can get on the network, right? These can be attacks can be increased by DHCP starvation attacks, where we just flood DHCP with information. And DHCP, we'll talk about that tomorrow. Dynamic Host Configuration Protocol. That's how, in most environments, you're going to get your IP address, right? So it's going to be assigned by a DHCP server. It's not crazy. A lot of your access points have a DHCP server built into them. ARP spoofing is when an attacker can make the system appear to be the destination that the sender was trying to get to, right? So we fool the system into sending the traffic to us instead of who it's really going to. Obviously, physical tampering is a age-old, well-tried attack. If people can get physical access to your devices, servers, network gear, your host, your endpoints, your host endpoints, a lot of times the game is over, right? So we have to, when we work in the cyber field, we have to work closely with the people in the physical security world. And for that matter, with the administrative security folks as well. We're all kind of one big happy family. We got to do that. Because if people can get to our network devices, sometimes they can do physical tampering. So we can as an attacker, we can plug into a management port on that switch and launch a number of attacks, even just shutting down the system, changing the passwords, just looping attacks where it shuts down the switch, because basically traffic goes out one port and right back out in the other one, so it just is a constant spin. We plug one cable into two different ports and it loops. We use some things, a little protection from that is spanning tree protocol, STP, which builds in a protection from that looping. So if it happens, the switch will be smart enough to know that's happening, and can kind of protect it. But if we lose um, physical control of our devices, any devices, it could be game over. When you really lose that, it's a bad thing, right? So how do we protect against some of these things? And we didn't talk about routers a lot. We talked a lot about switches. And honestly, as you're getting into the security field, if you're just joining in the security, that's why you're going through Security Plus, because you want to get into this world. A lot of times you're going to deal with switches a lot more than you deal with routers, right? And a lot of these things, these protections apply to both advanced switches and routers, right? So most routers are inherently insecure, not secure, out of the box. A lot of times they come with, a standard default password, or sometimes even no password. And remember, the routers, in your home or your small office, you probably have a router today. It's part of that access point, like we talked about on Monday when we were talking about devices. You've probably got a router there, and it's probably got the same default password, right? Unless you've been proactive in the past and went out there and changed it, it's going to have that default password. And it's easy. If I know that my neighbor's got a Netgear access point, I can go get the admin passwords from Google for the default admin password. So we want to change those right away. Known IP addresses and default routing tables are going to be set out of the get-go. Again, if we relate this to small office, home office access points, most access points will be set up for a private address range of 192.168.1 dot anything from 1 to 255. So you can change those. Maybe change those. It'll make it just a little bit harder to get in, right? The first line of defense is to configure your username and password securely, making it hard to crack. If you can do multi-factor, even better. A lot of times you can't, so just make a long password, even if it's just a sentence. Even sometimes works, or use the password requirements of your organization. A lot of times it's a long password that's complex, meaning it has uppercase letters, lowercase letters, special characters, and numbers, right? That makes it harder to crack. And just go through default configuration and lock it down before that router goes live on your network. Firewalls, saying it 3 times, maybe like Beetlejuice, makes the firewall appear. I'm not sure. They protect against and filter out unwanted traffic. Firewall can be an individual piece, an individual device. If you've been in an environment, you'll see it looks like kind of like a big switch. It's a firewall, though. It's got at least 2 ports on it, one on the outside, one on the inside, and you set rules up that allow things in and out. Again, we'll go back. A lot of people will be working with small office, home office stuff. So if you've got an access point, a lot of times the access point in the router has a small firewall built into it. It's going to allow you to put some protections in place. So when I'm talking about small office, home office stuff, a lot of times that stuff you can get at Best Buy, right? You're not going to have to order it through Cisco or something like that. You can go down to Best Buy, you can get a decent access point, and it's going to have these protective features built into it. A lot of people just don't use them. So I guess the rule here is, if you have one of these at home, go in there, look at these things at your home access point. Look at them. If you're in a small office, look at the, and you're the person responsible for security. Make sure you've done these things, right? Those firewalls built into those devices aren't always the best, but they're a heck of a lot better than nothing. And you have the ability to block certain kind of attacks, right? So we talk about just different types of attacks. Like if someone's coming from the outside with one of your IP addresses, that's probably a bad thing. You want to probably block it, because you shouldn't have an IP address from your internal network on the outside, right? Intrusion prevention systems, and I'm going to cover intrusion prevention systems and intrusion detection systems. So IPSs and IDSs, kind of in the same thought here. So the big things is an IDS, an intrusion detection system, monitors traffic, and it will detect something that it thinks is malicious, right? And we can have ones that are set on rules, that if it sees something that it knows in its rule set is bad, it will detect that and notify someone, either by, pager in the good old days, or an email or SMS text message or something like that. And then the ones that learn, the heuristic systems, learn your network. They're a little better, but they take a little more time to learn the network. They have to know what normal looks like before they can protect against things that aren't normal, right? So the difference between this is an IPS not only detects the attack, but it will make configuration changes to block the attack, where an IDS, an intrusion detection system, will only detect the attack and notify someone, right? Again, it's installed as a network-based solution. In organizations, you're going to see IDSs and IPSs as individual items, or sometimes they're built into routers and stuff, right? It's what we see again in small office, home offices. A lot of times those better devices will have decent IDSs and sometimes even IPSs in them. If you can use a virtual private network, and these things are getting cheaper and cheaper. There's a lot of VPNs you can buy from vendors that are decent, right? So instead of connecting, in an organization, you want to set the solution up, right? So instead of connecting directly to the router over just the open network, you can VPN with a VPN in. So you're going to connect securely over an IPsec or IPsec or SSL, secure socket layer tunnel, so that nobody else can see your traffic, right? So it's a little more protection. They can have connectors too. You can have hardware devices that do VPN concentrators or connectors, and advanced routers. And sometimes I think even some home office routers have the ability to do VPN. I know there's software VPN solutions from most of the malware providers now. So I think like Norton and their solution suite has a VPN you can get. I would say even, especially if you travel, this is not a networking issue, but if you're traveling, if you ever go to hotels or Starbucks or that kind of stuff, get one of the software VPNs. Don't, it's another layer of protection for your system, and that's not necessarily network. That's just generally do the right thing. Content filtering blocks or restricts access to certain websites. I think, what does that have to do with networking? I mean, we just want to we're going to add layers and layers of protection. So hopefully people don't go to malicious websites, don't go to malicious sites, and this hopefully keeps malicious traffic out of your network, right? And keeps it from attacking any of your devices, including your switches or your network fabric, right? This can be, again, servers have them. They can be an appliance, like Blue Code is a pretty famous web filter, web proxy, and some routers have the ability to do content filtering as well. It's funny, a lot of the again, small office, home office access points have the ability to do some basic content filtering as well. You're not going to get the robustness you're going to get out of something like a Blue Coat system, but then again, you're a small office. You may not need that. You may need to just block basic porn or block basic hate sites, or maybe even you're just blocking your competitor site so your employees don't go to your competitor site or something like that. Access control lists, or ACLs. These are good. They're in place in a lot of places. In place, just a crazy way to say things. You put an access control list in, and it's just like having that gate guard, that guard at the front desk that enables or denies traffic. If you don't have the reason or the justification to be on a switch or a router or a firewall or any of these smart devices, we can put an ACL in, and that means that we can't get onto the device to do configuration changes, or maybe we even have ACLs that restrict people from going across that switch or that router. So maybe we have a sectioned off area. Maybe we've got HR in our organization, and only people from HR should be in that area. So we put an access control list in, and people can't access that part of the network unless they're HR, unless they've been added to that access control list, right? It can be within the same device, or it could be a separate device. A lot of times it's in the same device. And we deny connections by computers that have an IP address outside the network number. So for a router, we may say we may blacklist or deny anything that comes from maybe a country that we know we don't want to do business with. So, and then protecting your system. Prevent DHCP or dynamic host configuration protocol snooping by closing off untrusted switches, right? Don't connect to anything outside the firewall or the network unless you need to, unless it's a justified reason. Prevent against ARP by reducing the time an event stays in the ARP cache. And it looks like spell check was trying to be my friend there. Not April, but ARP. What we want to do is we want to reduce the time an event system stays in that ARP table. So if someone puts a malicious entry into the table, it doesn't stay there too long. That's all we're saying there. We're reducing the time an entry stays in the ARP cache. So we just reduce that. That way we don't have invalid entries staying in the table too awful long. So that's what we got the pirate flag going.
Avast, ye scallywags!
That's what I'm saying, and we've covered some of the basic attacks on network devices. Didn't really notice how my shirt matches that flag. Wow, I'm always backwards here in the background. But again, I'll throw a link to this if you want one of these cool Amazon pirate shirts. Again, be an affiliate link, but it's not going to cost you any more than anything else. As always, subscribe. This content will be expanded in the Security Plus course we're putting online. Should be available the first part of April. Order soon, get that 25% off. That's the sales pitch of the day. Do please comment. Let me know what you think about the content, the direction we're going. Is it helping you? I'd love to hear it's helping you. Are you taking the Security Plus exam, or have you already taken it? What are your thoughts on Security Plus? Are you working in security now? Do you want to work in security? Are you trying to make the move into security, or cyber, if we want to tell it? They use the buzzword. And what are you doing? Especially you guys that are up early in the morning, that are on the live stream, 7 a.m. East Coast time. What do you guys think about what gets you up? Are you already up at this time of the morning, or are you just getting ready and this is something to watch? I'd like to know. I get up early to do these. I'm hopefully they're helping some folks, and that's really the reason. Like, comment, subscribe, hit the bell to be notified. Back on the trail, being here every morning at 7 a.m. East Coast. So let me know what you think. Join us tomorrow morning at 7. And I guess be careful, be safe out there. We'll see you tomorrow.